Find the total amount of area trapped between the x-axis and the function negative x squared plus 10x on the interval from x equals 2 to x equals 5. Alright, so this particular function, it is a parabola because the highest exponent here is 2, so that tells me it's got the shape of a parabola. It's facing downward because the leading term coefficient is negative, and it has the zeros of 0 itself and positive 10. So just to get a sketch of this, and you don't really need to know much about it to get a sketch of what's going on, but here we are. So this would be 0 and this would be 10. Now what I'm looking for is the area trapped under the curve between 2 and 5. And I suppose 5 actually would be that vertex point, so let me bring that over just a bit. So I want to know what this amount of area is right here. Well, the antiderivative evaluated as a definite integral between two endpoints will do just that. It will find the total amount of area under my function negative x squared plus 10x on the interval from 2 to 5. And you know what? I think I'm going to rewrite this as 10x minus x squared just because that makes the leading term coefficient not negative, and that's probably a little nicer to look at. Alright, so let's see. Finding an antiderivative is the first step. So this would be 10 times x squared over 2 minus x cubed over 3. Then we evaluate that antiderivative between 2 and 5. 2 goes into 10 5 times, so this is 5 times 5 squared minus 5 cubed over 3. And then we subtract 5 times 2 squared minus 2 cubed over 3. So at this point, we can just use the calculator here to help us out. 5 times 25 minus 125 over 3. And let me change that into a fraction just because I don't like decimals that go on forever. So 250 over 3. And then 5 times 4 minus 8 thirds. And change that into a fraction as well. So 52 thirds. And that would give me 250 minus 52, which is, whoops, 250 minus 52, which is 198 over 3. And let's see. Oh, you know what? That will divide. So divide by 3. That's 66. So there's my final answer.